Hello friends, this is Coach Veer again on my YouTube channel Coach Veer, and in this video we will discuss this question which is being asked on my FB Coach Veer page. The question is, the polynomial ax cube plus bx square plus cx plus d has integral coefficients, means the value of a, b, c, d are like integers. If AD is odd, BC is even, show that at least one root of the polynomial is irrational. We need to prove it. This question is from a RMO level question of exam 2004. Will provide you all the details in the description, and don't forget to share, like and subscribe my channel. It's very important for me, friends. So let's start. In this, what we need to assume it, let us assume let all the roots of this polynomial px, I am taking this polynomial as px is equal to ax cube plus bx square plus cx plus d are rational. Okay, just like counter proving, it is like I am thinking that all the roots are rational, and as it is a cubic equation, so at least one of the roots must be real. Whether it is rational or irrational, that does not matter, but the matter is the root must be real because it is a cubic equation and the complex roots occur in pair. That's why one of the root must be real. But here I am assuming, yeah, let or assume, any word you can choose, all the roots of this px are rational. Now we will do a little bit change in this. What change I want to do is, in place of x I want to substitute y by a. What happens to, because of this, if I do like this, I get on the right hand side a y by a whole cube plus b y by a whole square plus c y by a plus d. Now if you take the LCM, you will gonna get y cube plus by square plus cay plus d, or a square d, you can write like this, and in that denominator a can be shifted this side. So what I have substituted is here py by a. In place of x I have written this, then I got this. So I got this situation because a square is taken in the denominator, that is being multiplied on the left hand side. So I just changed it to py by a. Now what's the benefit of doing that? Now the benefit is that the first coefficient is 1, and because of that all the polynomial is being aligned in such a way, like suppose we have the roots as y1, y2, yz. These are the roots of this equation. Now when you see the first part, its coefficients, when its coefficient is 1, then the next coefficient is sum of the roots. These are like constants, not variable. Okay, so y1 plus y2 plus y3 times y square, this one must be negative. The first part is negative. This is negative because if you are not getting this, I can tell you like x square minus alpha plus beta x plus alpha into beta, like that situation you have seen. Sum of the roots, product of the roots, same way in cubics also it is applied, or in higher powers also it is being applied. So after this we have a positive symbol, then we have two of them in pair, like y1 y2 y1 y3 and then y2 y3 times y plus. Now what about this? you know the last one is the product of all, like y1, y2, y3. So here now we need to compare things. What's the comparison now? The comparison is whether we get like we have a situation like this. We can compare that um, y1 plus y2 plus y3 is equal to negative of b, correct? And y1 y2 plus y1 y3 plus y2 y3 is equal to ca or ac, anything you can write. Okay, now last one, y1 y2 y3, this is equal to a square d. Don't worry about this a square, this is in divide, this does not make anything like rational or irrational, because it is an integer. All abcd are integer. When this is being divided with something or like that, then it does not make any changes, it is just a multiple. Okay, so we got this situation. Now, or if you are getting doubt in this, you can just take it as p of beta or something. Okay, now the point is, check, these three numbers are being multiplied and you are getting a number, and that a square d, what's that in the question? You need to understand this part. Let me change the color. Now AD is odd and BC is even. So what it means? AD is odd. So if AD is odd, A square D is also odd. Or you can say both A and D are odd. Both A and D are odd. Same way when it is given that this other thing, what's that, BC? BC is even. When it is given that BC is even, so whether B or C or both of them are even, that is what is we can generate out of it. If like 2 into 1 is also even number, 2 into 2 is also even number, so both B and C or one of them might be even. But if you have a product as odd, then both of must be odd, like 7 3 7 5, like that. Okay, let's proceed further. So from this situation you can see that this thing is odd and y1 y2 y3 must be odd. Y1 y2 y3 must be odd. If they all are odd and we are adding all the odd numbers, we should get a odd number. So B is odd, correct? Because their product is odd. So if all the things are odd, then simply they are also odd. If you are adding 3 times an odd number like 1 1 1, if you add 3 odd digits, odd positive integers, then it is odd. Okay, same way we will look for this. A is odd, so C must be, this is a combination, all are odd, odd odd odd, so it will also give you odd. So A is odd, so C is also odd, because odd into odd will only make odd. So we got here that C is odd. But here is the contradiction. We just said that it is given that whether B or C, whether B or whether C, both of them are even or one of them must be even. But what we got is, we got B and C both are odd. So our assumption is wrong. assumption that it have all irrational roots is wrong. Okay, hence one of the root must be irrational, or at least one of the root, कम से कम. So here is how we can solve, but technically this thing is what I have done to make you understand this concept. But how to write this in exam, that is also I want to tell you. So first you assume all the roots are rational. Then what next you have to do is you need to create px, the given polynomial, ax cube plus bx square plus cx plus d. Then you are given that a, b, c, d, these all things are a, b, c, d, these all things are integers. Okay, next thing you have to do is transform. You need to write a square p times of some other thing you can take, it's up to you, or where beta I am putting in place of a alpha. So beta, this thing is cube plus beta square plus ac beta. This is just a variable, beta, don't worry about that. Now we got this. After that it's up to you whether you like we are said that beta is equal to alpha times a or a times alpha, anything you can write, or x. Let me write x. So x belongs to q, that is what we are letting rational. All the things of x are rational. Then it says that it is a multiple of x, so beta will also belongs to q, and moreover beta is a rational number, so beta must be in the form of r by s, where gcd of r and s is 1, means that is the smallest fraction. Okay, so when we substitute in place of that, we get r cube beta r square s. What I am just doing is, in place of beta I am just putting r by s. Because of that I get this situation, a c r s square plus a square d s cube is equal to, since all the terms, last three terms, this, they all divide by s. Okay, so it means s divides r cube, because if we take this side in multiplication, like r cube is equal to this all things, then s must be there. So r is means s divides r. Okay, s divides r cube means s divides r. This implies that s divides r. Okay, so when it divides r, so gcd, we have given that gcd of r and s is 1. So if it is dividing him, then s is simply just 1. That is the only possibility for s, because it is dividing r and r is not the 1, so it's 1. That is a possibility. Okay, another thing which I will go for the next is that when s is 1, the denominator is 1, beta is simply equal to r. If beta is equal to r, then beta is a integer. Beta is a integer. If its denominator is 1, then it is an integer. So that is what, how can we modify the question from this thing you are seeing. So now at the last point, since AD is odd, again the given condition AD is odd, so it suggests us that A and D, both the things are odd, and that other B, that also I should write, BC is even. That means either B or C are even, or both of them. So that is how we understand this situation. Next thing is, let's summarize this. AD is odd. This AD is odd. So what we get? This is the product of the roots. So product of the roots is B1 times B2 times B3. These are its roots. When they are being multiplied, we get AD square. How? See, AD square. This is what I said, beta thing you have to put. So AD square or A square D, A square D. Okay, A square D. So this is what you got. So all of them, beta 1, beta 2, beta 3 are odd. Okay, and you know sum of the roots, that is the second thing. Sum of the roots plus beta 3, this is equal to negative of B, and multiple of roots 2 at a time, b1 b2 plus b2 b3 plus b2 b3, like that combination we just need to make. Okay, that is equal to AC, and both B and AC must be in this condition. Odd is odd, so we are getting it as odd. Odd is again getting us as odd, correct? So we get a contradiction again. Hence our roots are not rational. One of the roots must be irrational. That is how we prove it. Hope you understood it. If you have any doubt, you can comment on my FB page or here on my YouTube channel. But don't forget to like and subscribe. That's important for me, friends. See you in my next video. Till then, bye bye.